Okay, we're live now. So.
All right.
So.
I can't hear you.
No. Does everyone have the preparation assignment up then?
Yeah, I'm ready.
Yeah, I'm ready.
Okay. All right, let's start with part 1 then of the preparation assignment. So question 1 is list at least 3 characteristics of the student's T distribution. So what'd you guys get?
I would say mean is 0, it's bell-shaped, and it's symmetrical. And of course there's like other ones, but that's like the 3 that comes to my mind.
I thought it was interesting about the more area in the tails. That was kind of cool.
Yeah.
Yeah, because in the book, it says, the T distribution has a mean of 0, but it has more area in the tails than the standard normal distribution. So,
and we can't use the normal applet, right?
Yeah, we can't now. So.
Yeah.
So I guess we'll go to question 2 then.
Yeah.
Okay, how many degrees of freedom generally does the T distribution have when it is used for inference for a single mean?
Isn't it just n minus 1? So it's 1 less whatever the sample size is, yeah.
Yeah, so if the sample size is 15, it's going to be 14.
Does anybody know why that is? Because I didn't understand why. I knew that's what it is, but
I think that's just what that statistician figured out for his formula to make it work.
Yeah.
Yeah.
N minus 1. That's all I know.
Yeah, me too.
Would you have anything to add, Jack, or is that good?
Basically, for this level, of course, it's like what he said. Like, you just have to know that. But I think if you really want to know, a simple answer to that is this distribution, the teacher's distribution, is a little bit he's less sure about it than a regular normal distribution, right? Because you're taking it from a sample.
Right.
You're modeling it from a sample. So to reflect that, like that level of increased uncertainty, he's making the denominator a little bit smaller to increase the deviation. I don't know if that makes sense or not. So like if you divide by n versus if you divide by n minus 1, if you divide by n minus 1, the answer is going to be always a little bit bigger. So that reflects a little bit more uncertainty, a little bit more spread.
Okay, that makes sense to me.
Sure. That's good, thank you.
I'm sure there's a more complicated reason that I don't understand either.
You're good. Okay, then let's go to question 3. What is the formula for the one sample T confidence interval? So confidence interval for the U and then the sigma when sigma is unknown. Sorry.
So it would be the sample mean minus T times S over square root of n, and then you do the exact opposite. Sample mean plus T S over square root of n. So
I guess I'm going to point out too that the S is the
sample standard deviation.
Yeah, sample standard deviation. Took me a little while to figure that out.
Yeah. It took me a little while too, but yeah.
Okay. Let's go to question 4. What are at least 2 differences between one sample T confidence interval and the one sample Z confidence interval we covered in lesson 10?
The sigma is not known. No, we don't know the standard deviation.
And then the scores are from different distributions. Like t-score is from the T distribution, and then the z-score is from the normal distribution.
Mm-hmm. Yep, that's what I got. And you already said it, but you can't use the applet to compute the t-scores.
Yeah.
So. Any other questions? Go to question 5 then.
Yeah.
When conducting a hypothesis test for single mean with sigma unknown, what is the formula used to compute the test statistic? What I got was the T. It's pretty much the same as the Z-score, but you'd have the sample mean bar X minus the population mean over sample standard deviation over the square root of n, or the sample number.
Yep.
Let's go to 6. What are the requirements that need to be met to conduct a hypothesis test for a single mean when sigma is unknown?
Always that the sample derived from a simple random sample, and then that you have at least the sample of the means is normally distributed.
Yeah, that's what I got.
Or the samples over 30. Yeah.
Okay. Are there any other questions before about, I guess, the reading before we go to part 2, kind of exercises?
Nope.
No.
Okay, part 2. So a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment property. He randomly selects 15 of his clients who purchased an investment property. Their ages are, and it has the list of 15 different age groups. So I guess we'll go to 7 then.
Yep.
So what are the requirements for creating a 95% confidence T interval?
Is that going to be pretty much the same what we talked about, the requirements that need to be met for a hypothesis test? Like it has to have the sample mean distribution should be like normal, and then drawn from a simple random sample.
Yeah.
Yeah.
Okay.
That should be the same answer as we have just covered in question 6. So.
Right.
Now it wants us to do the exercise. So on 8, it says, with the data above, calculate the mean of error and create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The T-score for a 95% confidence interval from the T distribution with 14 degrees of freedom is 2.1448. Round your upper and lower bound to 1 decimal place, but do not do this rounding until you have done all your computations.
I need to walk through that.
Yeah, so the formula, it would be then, wouldn't it be the
7.3. That was the mean.
so for all the 15 numbers, the standard deviation when I put it in Excel, the standard deviation for that is 8.827446.
Right.
Yep.
And then the mean is I got 46.73 of those numbers.
Right.
But
The formula,
then we would
46.7.
then to calculate the margin of error, we do the T-score times so the 8.8 divided by square root of 15. Is that right? Or
Right. Yep.
Yep.
Okay. So with the margin of error, we can add. What did you guys get for the margin of error?
2.279896.
You said 2 point what?
2.279896. Is that what you guys got?
1 second.
Error.
That's the 8.82 divided by the square root of 15.
I'm still doing it right now.
Yeah, same.
Sorry, he was crying up a storm. That's why I had to leave real quick.
You're good.
How old is he?
Just one. He had his birthday 2 weeks ago.
All right.
And I don't know if he had a fight with his 2-year-old brother, but he was crying up a storm, so I figured I'd grab him. And so he seems really chill now looking at the camera.
Oh, good looking guys, huh?
Yeah.
So Garth, I got a different answer. My answer was 4.88. 8.
Oh yeah, after you take the 2.1448 times that, it's 4.88992.
Yep.
Yeah.
And if we add those, well, we add it to the 47.
46.78.
Well, we should get the 51.62 for the upper bound and then the 41.845 as the lower bound.
Right. You just need to round it to one decimal. So 41.8 and 51.6.
Yep.
Everybody get that okay?
Yep.
Okay.
Okay, we'll go to 9. So now create a 99% confidence interval to estimate the mean age of all the clients who built an investment property. Follow the same rounding rules as above. The t-score for 99 confidence interval from the t distribution with 14 degrees of freedom is 2.9768.
Right. So you times that by the old 2.279896 and you get 6.78679.
Yep.
Mm-hmm.
Okay. Kind of took a brain shift for me to go from the last one to this one, but the last time we met, I mean, not the last question. But finally made sense about 2 last night.
Yeah, same here. Yeah, but if you add those, if we add the 6.78 to the 46.7, you should get the 53.51 and then the 39.948 for the upper and lower bounds for the answer.
Right. Exactly.
Okay. Let's go to 10. So now this is now using your class software, compute the 95% confidence interval using the data above. So here we just, instead of doing the t-score, we times it by, is it 1.96, right?
Yeah, for the 95%.
Yeah.
You just plug those numbers in that, what was it called? Quantitative inference procedures? Jack, are you bored?
Mhm.
Yeah, because if you do, and if we follow the one formula, you would do the 46.7 plus 1.96 times 8.827, whatever, divided by the square root of 15. you get the upper bound. If you do the 46 minus 1.96 times 8.827 divided by the square root of 15, you get the lower bound. So you get the 41.845.
And you know you got it right when it's the same answer as number 8.
Right.
True.
I took it out 3 on that one, but probably didn't need to.
Okay, so B, it's going to be the same as number 9. We just times it by, here's it 2.604. Right?
Are you guys using the software to do this, or doing it by hand? Because you did it by hand before already, right?
Yeah.
I have, oh, go ahead.
That's
You
awesome.
guys have the spreadsheet for this?
Oh, like the Excel
Mhm.
quantitative inference procedures.
Yeah.
Right.
Yeah, you can-
So basically, that's like a shortcut.
Right.
Okay.
They want you to do it by hand first, so you understand the process. But then later on in future chapters, you can just use the Excel spreadsheet, I think,
Right, nice.
to understand the process.
Yeah, those numbers just come out 41.845 and 51.622 on the spreadsheet.
I just spits it out.
Pretty cool.
Okay. So should we move on to question 11 then?
Yep.
Sure.
Yeah. How does the margin of error of the 95% confidence interval compare to the 99% interval?
It's a smaller, I don't know what the right word, like the distance between the lower bound and the higher bound, that range is a lot smaller
Yeah.
than the 99% confidence level.
Smaller for the 95.
Yep.
So can you guys explain why?
Because since nothing's changed with the sample,
Mhm.
like there's no number, like there's no more samples being done. It's just from that sample, to be more confident, you need to extend the range farther to encompass more of the data. So that's how I make sense of
Yeah,
it. It's like,
that makes sense.
yeah, to be more confident, you need a wider
having more-
range.
You don't have additional information. You just have the same amount of information to work with. So in order to be more confident, you got to cover more ground, kind of like hedging your bets a little bit.
Right.
Right. Perfect.
Okay, great.
Okay, yeah. Go to 12 then. So rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average of age 47. Use the 0.05 as your level of significance. Follow the following sequence of steps, fill in your answers at each step, and show all your work. So the first question is state the null and alternative hypothesis. What'd you guys get?
47.
47 for the null, and then alternative I got does not equal 47 because that's what we're trying to.
Yeah.
Because his clients is different than the national average. So,
Correct.
and then B, it says compute the test statistic. First, compute it using the formula and showing your work below. Then check this test statistic by inputting the data into the software.
When I did that formula manually, it came out minus 0.118. But in the software, it came out minus 0.117. But I guess that's close enough.
I mean, yeah, because I did it by hand, yeah, and I got the 0.118 as well. So, or when I did it using by hand. So,
Mm-hmm.
anybody gets anything else or?
No.
Oh yeah, it's the negative 0.117.
Negative.
Yeah. And then so or letter C, it says state the degrees of freedom. Since it's collection of 15 clients, it would be 14.
Yeah.
Right.
N minus 1. So yeah, 14. So D, sketch the T distribution and shape the area which represents the p-value. So how I did this. Yeah, yeah. So yeah, when I did this,
Wouldn't it,
I just used the book. Go ahead.
I was just gonna say, like, wouldn't it just be shading whatever is left from the negative t-score and then right from the positive t-score? So like negative 0.117, you'd shade all that's on the left-hand side, and then positive 0.117 would shade whatever's on the right-hand side.
Yeah, that's the area that we would want.
Okay.
In the bell-shaped curve, yeah.
Mm-hmm.
Just leaves a little piece in the middle.
So then now we says, yeah, use the software to compute the p-value. So like you said, we can get the area by getting everything from the left and right of those two t-scores. And I got 0.909.
Yep.
You know, and it's interesting because if you use that student's T probabilities sampling thing, whatever you call it, the applet, and you put in negative 0.117, it comes out 0.9143. So it's kind of close, I guess, huh? If you put in the 118, it's a little bit different. Is that right, Jack?
All right, what did you say, Garth?
Well, when you use that T probability thing instead of the normal, you know, the applet.
Huh?
Just a second here now. Never mind. I was looking at the wrong thing.
Oh,
Duh.
sorry. I was still working on the problem
Yeah.
by hand. So
Yeah. I was looking at something besides the egg. I was still back on the curve of it. So yeah, it's 0.909. That's what the Excel spreadsheet figures for you. That look on your face was worth it though.
All right. Okay. Let's go to F then. Or Jack, do you have anything to add that what we're going through, or I don't know?
honestly, I was just still doing it. I was still on part B, like working that out by hand when you guys were talking. And I didn't want to like interrupt you guys, so I know you did. I know C was right because I overheard that. I know D was right. I overheard that. E, I assume is right because it's software stuff. So go ahead.
All right. So should we move to F then?
Yeah.
All right.
Yeah.
So I would fail to reject the null hypothesis since
Right.
the p-value was more than the level of significance.
Yeah, the value's larger. Excuse me.
And then
Yeah, go ahead, Daniel.
and then like the last one, saying like the conclusion, I just say there's insufficient evidence to conclude to reject the null hypothesis, or I don't know how would be the best way of doing it. I'm not really good with writing.
It's that old, we have insufficient evidence to conclude that the average age of the second home buyers is more than the national average. It's different than the national average.
So
Yeah,
questions, so questions like that, you have to include kind of like the noun and whatever, like the actual nouns that are in the study, like saying second
Yeah.
home buyer and like customer. Okay.
Yeah.
I'll make sure. to
Basically, you
include
try to state it as closely to your hypothesis as possible.
Okay.
Like, same wording you use hypothesis.
it. Okay.
All right, great job.
Hey,
Nice.
Okay.
So I'm going to stop the broadcast then.
Hold on, did you guys do the quiz together?
yeah, but we don't like.
We stop the broadcast and then we do the quiz. We stay online. Yeah.
What's that?
I stopped the recording right now,
Uh-huh.
and then we all stay on and do the quiz together.
Oh, okay. You can broadcast a quiz. You don't have to. It's up
Say
to you
that again.
guys.
I didn't.
Preferred, yeah.
I mean, you guys met already, so I don't mind. Like you guys do the quiz and broadcast.
Okay.
So you're cutting out for me. So he says I should. Yes, or I shouldn't for the quiz.
He said like you don't have to.
Okay. Okay. I'm just gonna stop it though. I think I don't know.
No,
That's what
that'd
I'm
be good,
used to,
just in case I
so.
pick my